Hello, my name is William Edward, and today I'm going to be talking about contrasts, how to perform a contrast in JMP, and the statistical ideas behind contrasts. So first of all, we have to ask, what is a contrast? So a contrast is essentially taking one group of sample means, it could just be one or more, and another sample group of means, and asking, is the population mean of this one equal to the population mean of this combination of sample means? And so essentially the simplest form of contrast would be very similar to what we see in a two-sample t-test, where we're asking, is it true, the null hypothesis, that mu1 equals mu2? Or we could write it a different way with the same meaning, that mu1 minus mu2 equals 0. And for example, we could be comparing, the prevalence of different favorite colors among children and asking, is green as common as yellow? Is red as common as blue? And so on. However, this framework of linear combinations of means, testing if that's equal to 0, this allows us to test some more complex types of functions, where we could be asking, is mu1 minus half of mu2 minus half of mu3 equal to 0? And you can do that for essentially any combination of different sample means, as long as all of your constants that you're multiplying the variables by add up to 0. If they didn't add up to 0, then we'd be sort of testing if some variable was equal to 0, and that's not what a contrast is. There are certainly other tests for that. So one example of this could be, if we're looking at this sales data on the right, we could be asking, is the sum of central and east equal to sum of south and west? Maybe you're looking at either a central east marketing campaign or a south and west marketing campaign and trying to decide between the two. So you want to know if one is bigger than the other, one of those like regions that's an agglomeration of multiple different regions. And so now we're going to look at how to perform these in JMP. So we're going to first of all pull up some sample data. This is JMP 15.0, and they generously provide a lot of different data for us to use just for like basic trying out the JMP software. So in the analysis of variance, we're going to use the typing data. It's a fairly simple data set just made for a one-way ANOVA. And we're going to fit a model of speed based on the brand of typing software being used. And so right off the bat, we see that there's some high levels of significance, and we can look at the statistical significance of different levels of the brand. So you can see that the speed type is statistically different, and the word-o-matic, which is the intercept, is also statistically different from 0. However, these are not contrasts. These are comparing, individual effects to the average, which is not entirely what we're interested in. But if we go to the individual effect, we can make a least squared means contrast. And here we can see we can set these up and create whatever combination we want. You can even weight different means more or less than others. In this case, we don't really have a reason to do that. So for this contrast, we're going to be asking, is the mean of regal and speed type equal to word-o-matic? So as we've seen here, word-o-matic is far more negative than the others, so we'd be pretty surprised if these were equal. And indeed, we find the combination is not the same as word-o-matics. And however, we can see that this isn't the same as the tests going on in the other place. We have a different p-value, a different f ratio. And yeah, so we can do more contrast. We could do a single contrast. Is regal the same as speed type? And as you can see, there's all sorts of combination. And we see that these are definitely not the same. They're 10 points apart, so very different. And so that's essentially the idea of contrast. You can use them in JMP. You can do them even when there's multiple variables. And yeah, thanks for watching.